Okay, does anybody know how to factor that? Okay, let's get going. Sum and difference of cubes. And then we're going to move to quadratic form, which I call quadratic impersonation, because I think I'm funny. Shut up, Mike. Where are you now? Because it was funny. Okay, can you factor that? How? Okay, now I'm waiting for the rest of it. Okay, let me show you. I just wanted to give you.
X squared plus 4.
Okay, let's give you the formula. This breaks into that right there. So you see where they got the 2?
Yeah.
Okay, here's the formula. No, you're not the first. You're not even the first person to say that today. Well, it's math time, so get over it. Can. Choose not to. It just did. Okay. What is y in place of 2? Okay, so we're just going to put a x is the same, so we'll just leave x's. But we're going to put a 2 in for every y. So it's x minus 2, x squared plus 2x plus 4. That's called the difference of 2 cubes. Yeah, you're factored now. Okay, so you can't. It's not factorable. So this is called the difference of cubes. Oh, handwriting. You'd think Michael Lewis was up here. Insult to the day. I have to get at least one a day in on you.
I think people are
Pretty much. Yeah. Okay. So that is just a formula. If you have 2 cubics that are subtracted, okay, you might have to break it down, but that's the formula you use. Okay. It's another way to factor. Okay, I already showed you the difference of squares. You guys know that, right? So if I had x squared minus 4, okay, these are similar ideas. They're all, in math, they're all kind of grouped together. Okay. This is called the difference of squares. Okay, so I think you get the idea there. Ah, good question. So we have a sum now, right? We have a sum now. So we have x cubed plus y cubed. There's a different formula for that one. No. All of the terms are the same. You just change those 2 signs. That's it. So it's x plus y. X squared minus xy plus y squared. That's the only difference. Okay. So plus starts with plus, right? Sum starts with plus. Difference starts with the difference. That's kind of how I remember it. Y squared. Oh. Okay, if you want to be that particular, you bet. So they're very similar. Oh, what was that? So what if I have something such as x cubed plus, yeah. Hey, that's a good idea. Who said that? Say it again louder. Yeah, what's the cube root of 729?
9.
It's 9. So we have, we finish it off. Finish it off on your paper and we'll see if you get the right answer. We've been through this. These are not good enough for you. I do remember that. It's much better, but because you. What am I going to write down here? Beautiful. It's just formula. You just have to recognize what to put in it. Okay, so another way to factor sum and difference of cubes. What if you run into something like this? Okay, so Matt has a good idea. Now it's a difference of cubes, so it makes it easier if you kind of need to adjust things. Sometimes this might be written like, here's another example. This is separate. Whoa, okay. What's 6 to the third power? 216? So we can write that as 4 cubed minus x cubed, right? And now this term is in place of the first term in the difference. So it would be here. Okay, so we would have 4 minus x. Oh, sorry. I even just said that, didn't I? Now we're on track again. Thank you for the. So that would be factored there. So you can switch terms around. You can do whatever you want. It's still gonna be. You're gonna be able to do it.
Why did you change the plus 1.5 to
Well, that's 5 cubed. I factored a -1 out. So factor a negative out of here, it becomes positive, and a negative out of here becomes negative. Negative times a negative is a positive. You could also, you can write this one like that if you want, and do what I did on the right side. There are some ways to manipulate these into what you need to factor them. Right, so you could switch these and make it a difference of 2 cubes, or you can factor a -1 out. Does it make any difference to me? Okay, so just some ways to manipulate things. Are you good with that? I feel like I'm aging as we wait.
Well,
Just kidding. Yeah, but I can actually feel it this time. It's bad. So my jokes go a little deeper sometimes than most. It's a smart guy joke. It's yeah, pretty much. Okay. The next couple of things are quadratics. I call it quadratic impersonation. Everybody else formally calls it quadratic form, but we're just basically using quadratic techniques to solve these. Factoring and the quadratic formula are the two big ones.
Uh-oh, you're gonna die.
I'm not going to die. I have the tools to defend myself. Called an electrical plug. And a knife. Okay. Anyways, let's do this.
I think he would win the Hunger Games if it was between all the staff.
I doubt it. I would get some fierce competition, and I would have a really hard time with.
Come down to you and Whitley. Yeah. I feel like they have enough in a lot.
I bet you we would. I really do. Okay, the problem with me being in the Hunger Games in the arena is that I have a really hard time killing people. Just not within my being. I know. No, I haven't. That would be a good logical extension of what I said, though, wouldn't it? Let's put it this way. I have a hard time killing animals hunting.
Yeah, but the animals
I
aren't
still
coming
do
at
it.
you trying to
No,
kill
they're
you
not.
if
I
they
know.
were, you're like,
All right. Okay. Well, okay. Let's get off of that because, yeah. All right. Stop. Stop it, children. Okay. Left, right. One's a quadratic. You can factor it. What are the factors? Okay, somebody said it, so I'm going to write it down. Okay, we could use the same technique here, except we have a sixth, right? The key is to note that this is 2, that's 1, right? Half of 2 and 0. So this is 6, half of 6, and 0. Use substitution you can use, yes. This is just a little, the concept's a little easier. I showed everybody use substitution last year, and it didn't go over very well. So it's still -3 and +2. But what are my exponents? Right. Okay. So x cubed times x cubed is x to the 6th. And then the outers give us the cubic. And then the last give us the 6th. Okay. So we're just manipulating it to touch. Using quadratic techniques, we'll be able to factor it. Okay, factor that one. That's supposed to be an 8. It's a snowman with a fat head.
You got in a car accident.
Mr. Gonzalez.
Have you ever been in a car accident?
Uh-huh.
You have? Is it scary?
No, it's actually
Not at 5 miles an hour.
That was your car accident.
Yeah.
How is your car?
What did you do?
What'd you hit, or what hit you?
How about we factor this? I wasn't driving. I was sitting in the back seat.
Oh.
Now, without a seatbelt on, that was a bad idea. Okay, where are we at before the battery runs out and I die?
Just give him time, guys.
Oh, yeah.
Oh.
6 times 2 is 12. 6 plus 2 is 8. Okay, now the key again. 4, half of 4, nothing. The pattern. Okay. 6, half of 6, nothing. 2, half, nothing. You got to follow the pattern.
If it doesn't-
Then you can use quadratic factoring techniques.
if it doesn't, then you, is it just not factorable?
No, it doesn't mean it's not factorable. You just can't use this technique. Okay. All right. The last thing you can do is use the quadratic formula on some of these. Okay. We know what A, B, and C are, so we can plug those in, right? Okay, the question is, this is not a quadratic. So it's not x equals. This one's x squared equals. Okay, that's the key there. Right, because it's x squared to the second power, we know that that's going to be x squared equals. So when you get your answer, square root the whole shooting match. Okay, and you're probably going to get 4 numbers because it's a quartic. Remember the fundamental theorem of algebra, 4 complex roots. What if that's a 6th? What would I put here? A 3. If it's an 8th, I would put a... Okay, so just make sure it follows that pattern I told you. Then you can use this as well. Okay? Any questions? Well, that's not what I wanted to do. Okay, we're going to do some classwork around this.